Okay, everyone, welcome back to our statistics class notes. We're now on page 126 in section 8.2, where we're talking about hypothesis testing, and we're still trying to make sure we hammer home this idea of a p-value at this point. So for each graph, indicate whether the shaded area could represent a p-value. Explain why or why not, and if yes, state whether the area could represent the p-value for a one-sided or a two-sided alternative hypothesis. So yes, this could represent the p-value, these shaded areas, for a two-sided test. In other words, where the alternative hypothesis is p is not equal to p naught. Okay, why is that? Because the p-value is the probability of getting your test statistic or one more extreme. So say your test statistic was right here, your z-stat. So the probability of getting that guy or one more extreme is this area in the right tail. But since it's a two-sided test, I could have been on the left side as well, minus that z-stat, and one more extreme is to the left of that. So these are symmetric, so these are the same area, but I double them. Okay, I double one of them if I think of it that way. This is not a p-value. It's not the probability of getting the test statistic or one more extreme. This is what is the probability of what's inside your test statistic. So this is not any kind of a test that we would do. This is not a p-value. All right, so as another example here, let's suppose we have a poll of 400 randomly selected voters in a city, and it found that 208 of them, so that's a little bit more than half, right, favored a school bond measure for public schools. So based on this poll, could we conclude that a majority of voters in this city, which is more than 50%, favor the bond measure? Okay, we're going to use the significance level of alpha equals 0.01. So let's go through the 4 steps. First, we hypothesize. So the hypothesis, now we want to be able to show majority. So the majority that we want to be able to show in the alternative is that p is greater than 0.5. So the null hypothesis then is that p equals 0.5. Now technically that means 0.5 or less, because if we're doing a one-sided, but that's okay. We always write just an equal sign in the null. The preparation phase is to check the 3 conditions of the central limit theorem. Right, the sample is random and independent. We do have a large enough sample because I should expect about 200 that favor and about 200 that don't favor it. Right, 200 successes. We do n times p naught, so 400 times 0.5 is 200, and n times 1 minus p naught is still 400 times 0.5, which is 200. So those are both bigger than 10. And is it a large population? I would say it's reasonable to assume that there are more than 10n, which is 4,000 voters in the city, because we did a sample size of 400, so there just has to be more than 4,000 voters in that city. So if I let StatCrunch do all this, right, this is what I get. I get my 208 successes out of a total of 400. It comes out to a sample proportion of 0.52. The standard error then is 0.025, and it gives me a z-score, or a test statistic, which is a z-stat, of 0.8. Not a very surprising test statistic, right? That means our sample proportion 0.52 is only 0.8 standard deviations above our null of 0.5, assuming the null is truly the middle of the normal distribution. So that gives a p-value, the probability of having this test statistic or one more extreme to the right, 0.8 or more, which is 0.2119. So how do we interpret that? Since the p-value, which is 0.2119, is bigger than alpha, which is 0.01, you do not reject the null. We do not reject HO. So we cannot reject that p is equal to 0.5 and then say we have enough evidence to support that p is greater than 0.5. So that means there's insufficient statistical evidence to conclude the majority of voters in this city favor the bond measure.